Well, hi all, it's John here, the founder of John Academy once again, and today we are a bit more elegant wearing red because we are gonna finish the last 5 exercises of the Regents August 2025 geometry exam. And these are gonna be the ones that have to do with proofs. So let's start first with this one, number 5. They talk us about a parallelogram, no? So we could draw that. Let's see. So let's take a parallelogram here. We're gonna take out these corners. Okay, and for this parallelogram is called ABCD, no? So we can call A, B, C, D, the vertices in this order. And then they also talk about the diagonals. So let's draw the diagonals. AC is this one, no? There. And the other diagonal is DB, no? Okay, perfect. And they intersect at E. So this point is gonna be called E. Okay, which of the information is sufficient to prove ABCD is a rhombus? For it to be a rhombus, what we need is that the parallelogram has, well, both diagonals of a parallelogram need to have a 90-degree angle, no? They need to be perpendicular. So we can already discard the first two options, no? These ones, they talk about some side congruencies. And then for the perpendicular ones, 3 and 4, let's see which ones involve both diagonals. They call this AC, which is the one here, and BD. So it's gonna be the fourth option, no? And then, yeah, we can check also with the drawing. So even better. Let's see now this next one, number 11. So they gave us this drawing, no? CD is parallel to AB. So we can draw it here also. And CB bisects ABD. That means that this angle has the same size as this other angle because it's bisected, no? Split it into half. And then they tell us here which statement must be true. So first of all, two of them are side congruencies, CD and AB. Well, for this one, it's pretty clear this is completely false, no? Because A could be even more to the left. We didn't have any requirement for that. The only requirement involving A and B is that they were parallel, no? So this one is not going to be true. AB congruent with BD. AB and BD. For this one, happens something similar. The parallel line could be lower, no? And then you could still have a bisection, no? So that one is also false. CDB is a right triangle. CD, so the angle here has to be right triangle. This is not the case, no? Also, yeah, they didn't give us any information about that corner at all, no? And the last one, triangle CDB, yeah, right triangle, the right angle could have been somewhere else, but either way, we don't see any insights for that, no? And CDB is an isosceles triangle. So for this one, what happens? You have two parallel lines, no? And then this one, we can color it in yellow, is the transversal between them. So we know this angle is the same as this angle here, the one here, no? Because of alternate interior angles. And as it was a bisection, that one is also, as we draw here, the same as this other. So now we have two angles, these two in blue, that are equal size. And if we have two angles that are equal size, we are going to have also two sides that are equal size. Therefore, it's going to be an isosceles triangle. It's going to be the fourth option. Now let's jump into exercise 19, a very easy one. What can we see here? GT and PF intersect at E. The angles P and F are congruent, no? So these two are congruent between each other. Perfect. And then what else do we know? These angles, we can say angle, well, it's a multiple choice, but we can write it here. Angle PEG is congruent with angle that will be FET, no? Because of being vertical opposites, no? And then now we have two angles that are congruent between each other. So we can use the angle-angle criteria and say the triangles PEG and, or that triangle is congruent with triangle FET, no? That would be FET. Perfect. So now that we know both are similar, what happens? We have to check in which of them this holds, no? So E is always E. And angle P is with F. So P with F, that's gonna be here, no? As we see, PF, and then the angle at G is also gonna be congruent with the one at T, no? So that's gonna be this fourth option, therefore. Because of corresponding parts of corresponding triangles are congruent, no? So now let's go into number 34. This one is more of a developing question, no? So we have to do some arguments here. So they gave us also a set of axes, we can use it, no? It's gonna be easier. So minus 1, 3, that's gonna be here, R. What else? 2, 7 is gonna be somewhere here, no? 2, 7, okay. That's E. A is 10, 1, so that's gonna be over here, and D is 7 minus 3. 7 minus 3 is here, D. So we name this, no? And then we draw the lines for the rectangle, no? Yeah, it's a quadrilateral at first, no? But it's gonna end up being a rectangle. That's what we need to prove. And what can we see? So in order to prove that, we should first, well, we have to prove two things, or we need two things. First, we need to show that the sides are parallel between each other. These ones, that way. So in order to do that, well, we have to calculate several slopes, no? So the slope between RE, this one is gonna be, let's see, we take the y's and subtract them, 7 minus 3, and then 2 minus minus 1, which is plus, no? So this is gonna be 4/3, no? Which is looks positive, no? In the drawing looks good. And then this one has to be the same to AD, no? Or DA, we can call it as you want, actually. DA, AD doesn't matter much. And for this one, let's do the same thing. So first with the y's, minus 1 or minus 3 minus 1, no? Divided by 7 minus 10. And this one is going to be minus 4 over minus 3, which minus minus becomes plus, so it's the same. So with that, we already proved these two are parallel, no? Therefore, RE is parallel to DA because both have the same slope. And now let's go with the other two. We need to say that slope EA is gonna be what? Slope EA is gonna be 1 minus 7. Then we have 10 minus 2, no? Is that? Yeah. 10 minus 2, that's gonna be minus 6 over minus 6 over 8. We can simplify it somehow. No, it's going to be minus 3/4. It's negative, no? Also matches with the drawing, no? We can even check here, no? In the chart or in the diagram, no? At the same time, no? To make sure we didn't have any mistake there, no? Okay. So here the other one, RD, is going to be minus 3. We have minus 3 from the D, minus 3 again, and 7 minus 1 is going to be plus. So this is going to be also minus 6 over 8, and it's also minus 3 over 4. Therefore, both have the same slope, and that means both are parallel. So we can write again EA, segment EA parallel to segment RD. So with that, we prove already the parallel sides between each other. And now we have to, well, and now we can see also these two are perpendicular between each other because slope RE times slope EA, for example, equals to 1. Yeah, it has a minus and it's flipped, no? So it's going to be perpendicular. We could say RE perpendicular to EA. That's why. Perfect. So we have also a 90-degree angle on the parallelogram, no? Or in the quadrilateral, no? In this case. And now we have to also check the distances. So let's check the distances. We need to see that sides RE, yeah, let's calculate RE. The distance for that one, we can see it, well, we can do it with the distance formula really, no? So it's gonna be this square and this square. Is using Pythagoras, no, at the end. So that's gonna be the difference in the y's here is 4, no, and the x's is 3. So it's gonna be square root of 4 squared plus 3 squared. And this is gonna be what, 16? So it's gonna be 5, no, 25, square root of 25. RE and now AD we can do also, should be also 25. We have to see that we have 3 and 4 again, no? So it's also gonna be 9, yeah, 16 plus 9, no? Therefore we get 5 here. Both have the same length. And at the same time, we are gonna do EA, no? EA and RD, no? Both need to be the same distance also. So let's check with the triangles over here, no? So, well, this was 3 and 4, no? We said we can write it all. It's better even. And this is gonna be 7. No, sorry, 8. I believe, yeah, 8. And this is gonna be 6, no? Yeah, it's 3, 8, yeah. So 6. And over here, we can check at the same time. This is also 8 and this is also 6. So both are 6 squared plus 8 squared. And that's 64 plus 36, which is square root of 100, which is 10. And this one is the same way around, no? Basically. 8 squared is 10. So now we prove the distances are the same and they are parallel and perpendicular, no, between each other. So now we already proved, no, this has to be READ is a rectangle, no, and we could write some explanation, no. Well, at the end, the reasoning is what we wrote over here, no? It will be these two are parallel these two all are also parallel. They both are perpendicular later on, and the distance is matched, no? So we could write RE, distance RE equals distance AD, and EA, distance EA, is the same as RD. And with all of that, no, because of all of this reasoning, it's gonna be a rectangle. Perfect. So now let's jump into the last exercise of the exam. This is out of 6 points, number 35. And there are different ways to solve it. It's a bit more of an open question, no? So let's see. They gave us also a quadrilateral, ABCD, no? Here we don't have any axis, no? Because there are no lengths, no? Or no coordinates. So we have ABCD is a quadrilateral, no? And they tell us side CD is extended through D to point E, okay? AFD and BFE bisect each other. Bisect each other and DE congruent with CD. So these are the two main things we need to use. Okay. So let's see. First thing we could do here, using the fact that they bisect, no? We could do, or we could say, no? Let's say number one, AF, no? Is congruent with FD. And at the same time, yeah, these two, no, basically. These here are congruent, no? And these two are also gonna be congruent. So we could say EF, no? Congruent with FB. Perfect. And the reason is because AFD and BFE bisect, no? Well, that. And at the same time, this was given, no? Well, you could include it also as a first step. Good. So we got that already. And we can also see these two are the same, no? These two angles because of being vertical opposite. So we can write angle AFB. AFB is congruent with angle EFD, no? EFD, no, yeah, DFE, I will call it, no? DFE. This is vertical opposite angles, no? Very good there. Okay, DFE, okay, that's good. And now next, because of these two things at the same time, we have the angles and these sides, no? We can do it with colors maybe. It's a bit easier for this one maybe. So what we could see is that we have two sides are congruent and the angle in between. So this is something familiar for us, no? This is gonna be the SAS criteria to show triangles. The triangles are AFB, no, we can call it the first one, AFB, congruent with triangle, and let's see that the vertices match, is gonna be DFE, no? DFE. DFE. That looks good, no? E with B, okay, very good. And from there, we can do some more steps now. Why? So as we said, yeah, as we shown this triangle, yeah, the congruence between these two triangles, we can use the CPCTC criteria, no? So we could show, let's do this in purple, that AB is going to be congruent with ED, no? So let's write it here. That will be AB congruent with ED. And the reason in brackets is going to be congruent parts of congruent triangles are congruent. And on top of that, we also have another one that is going to be these two angles. The angle at E, no? The only angle at E is congruent with the angle there, no? So that's going to be angle A, B, BF, no? And the reason is the same one, no? Congruent parts of congruent triangles are congruent. Actually, we could flip these two. The order doesn't matter at all because both come from the SAS, no? But it's going to be more helpful for us because we need to do the next step from this fifth one, no? So it's more relevant this way. Okay, so the sixth step, now that we've shown these two sides in purple, we could also say these two are also gonna be, yeah, this is congruent with that one, no? ED, so using the fact given here in the exercise, no, at the beginning, we could say number 6 is gonna be that AB, no? AB, yeah, we bring it here, is congruent with DC. And this comes from the fact that D was congruent with DC. And that was also given, no, in the exercise. You could write it also as another step, no, if you want. Yeah, this one here, we also said it was given, no? So we can add it here also given. It's a fact that was given. Good. And now we have two sides of the quadrilateral that are congruent. The only thing we need to prove now is that they are also parallel. So in order to prove both are parallel, we have the fact here that yeah, we have a transversal line and the angles E and B are the same. So this has to be also AB has to be parallel with DC. Yeah, the whole thing there, no? So we could write AB, segment AB is parallel to, we can call the whole thing EDC, no? Because of, well, first we could write the, yeah, we have the angles already. Because of two angles are congruent in a transversal, no? Angles, angle E congruent with angle, how did we call the other one? ABF, no? And there is a transversal, no, in between them. So that means they have to be parallel, no, those two sides. So now we got everything needed, no, because of these last two things, basically. We can do like this kind of a diagram. Because of these two reasons, ABCD has to be a parallelogram. ABCD is a parallelogram. And for the reason for that, yeah, parallelogram. The reason for that is this last two, no? So we have two sides congruent, no? Congruent and parallel between each other, no? So that's all, no? There are a bunch of steps. I mean, there are also other ways to do this last one. It's a bit of an open exercise, as we can see here. But this will be one of the easiest probably, no? As we can see step by step, and that's how we get that done, no? So well, that has been all of the exam of all of the Regents August 2025 geometry exam. We see us in any other videos, no?